Okay, everyone. So as we left off, we currently have the mean and the median of our data set. So we know that the mean, and we can see actually that there's a fair difference between these two, right? How will we determine what the actual shape of this data set is, i.e. whether we should use the mean or the median? Really what we need to do is create a histogram. So similar to the example that we looked at with the US population, we would want to create buckets. The size of the bucket would depend, probably I would say in this case, maybe 10,000 person buckets, and we would actually need to count how many values were in each bucket and kind of get a sense for what the shape of that is. The other way, there are kind of mathematical ways that you can do this. Generally speaking, though, you're kind of always safe using the mean because, the median, not the mean. You're almost always safe using the median because in a normal distribution, the mean and the median will actually be the same. However, it is worth kind of figuring out what the shape of that data set is. For our purposes, again, we'll go over how to find that shape a little bit later. But just for kind of performing our calculations, I want to highlight again that we have now our measures of central tendency. We also want to think about spread. And spread, again, tells us something about the shape. And so going back to this demonstration, this is, again, just looking at that bell curve. This is showing us actually the relationship between the median measures of central tendency and spread, which is this Q1, Q3, and this Q3 plus 1.5 and Q1 minus 1.5 times IQR. Don't worry too much about those yet. IQR stands for interquartile range. All of this is actually very simple to do, even though I know that sometimes these diagrams look complicated. But the basic point here is to know how much of the data set is in a particular range. And so when we're talking about the median and the quartiles, it's actually very easy to do. Because what have we done in creating the median? Well, we've actually divided our data set into two parts that have an equal number of data points within them. So again, I can confirm this. I always like to confirm it by saying, yep, okay, this is, let's see, how many rows here? I look at my count and it says, yes, there's 9 rows above and 9 rows below the median. So that is definitely the median. If I want to find Q1, okay, so what is Q1? Q1 divides the lower value half of our data set into two. That's all it does. Q is for quartile or quarter, right? So as we can understand, we're dividing our data set into quarters. So here I have, once again, 9 rows. And so 9 divided by 2 is 4.5. I round up. So so I'm looking for the 5th data row, but I need to add 1, if you will, because I have one row that I'm excluding because it's the header row. And so that's going to mean that I look at row number 6. Okay, so again, I'm going to highlight this. My Q1 value, again, is just the value that appears in that row. And again, I'm going to do the equals. Okay, and Q3, which again just divides the larger half of my data set, the larger value half of my data set into two. I'm going to follow the same process. So there should also be 9 values here. So again, I'm looking for the 5th row, but I choose to do this where I exclude the median. There's 2 different ways you can do this. You can either include the median in both cases or you can exclude the median in both cases. I prefer to exclude it. The differences are not significant, even though I know you might be like, wait, I'm going to get like a totally different number. The reason why it's not significant is because basically when we find these measures of central tendency and spread, they're in a sense just estimates. And so we're never going to, for our purposes, we're never going to report like this was in the 4th quartile or something like that. We're using this as a tool for ourselves, again, to understand how extreme a particular value is or is not. So even though it might seem like it makes a big difference, the whole point of it is it doesn't actually make a big difference. And what it does is it helps you understand that there is kind of natural variation within the data set. And so we rarely will talk about specific numbers, in fact, because, especially with respect to these calculations, because they are meant to represent patterns and trends, not, this number is, 2 digits higher than this other one. So anyhow, in this case, therefore, I'm going to exclude the first 11 rows. So if I take 11 plus 5, right, or it's 12 plus 5. I always find this very confusing. 11 plus 5. 11 plus 5 is definitely 16. That part I know. And if I did this correctly, then I should have 1, 2, 3, 4. Whoops, no. Oh yeah. So I exclude the first 11. So 11 plus 5 is 16. 1, 2, 3, 4 above, 1, 2, 3, 4 below. So this is my Q3 value. And I'm just going to go ahead and do that. Okay. So we're going to go one step further because I feel like we're on a roll. And we are going to look at the kind of outside figures. So we now know that what does this mean? If we look at the median, okay, what this means is that 50% of our data points are lower than 53,562. 50% of our data points are higher than that. If I look at Q1 and I see the 15,937, what that means is 25% of my data points are less than that, have values lower than 15,937. And in Q3, it means 25% of our data points contain values higher than 114,865. Hopefully that kind of makes sense, right? Literally all I'm doing is dividing it into quarters. So again, a way of understanding where, how far away or how unusual a data point is, there's this kind of additional parameter. So we've divided our data set into quarters, and that's not bad. But we have these other boundaries that we can calculate. I just call them the upper bound and the lower bound. And to calculate those, the first thing we need to do is determine the numerical distance, right? The value difference between Q1 and Q3. So that's very simple to do. It's obviously just subtraction. It's a difference in subtraction. So I'm going to say IQR. And the IQR is just Q3 minus Q1. Okay, no big deal. Pretty big difference there, if you notice, 98,000, almost 100,000. And that is going to, again, help us understand a given data point and say, is this really unusual or not? So then coming back to here, we say, okay, well, what is the upper bound? Well, the upper bound is the value of Q that's in Q3 plus 1.5 times that IQR. So the first thing I'm going to do is I'm going to type in here upper bound. And what is that equal to? Well, we're going to take IQR, right? We're going to multiply it, that's the asterisk, times 1.5. Okay. Now I'm going to wrap this in parentheses, even though Microsoft Excel is going to give me a big kerfuffle about it. Okay. Because I want to make sure that maybe some of you remember kind of order of operations in math. I want to make sure that multiplication gets applied just to the IQR and 1.5 and not any other way. And then I'm going to add the value in Q3. Okay, so you can see I've kind of done it in reverse order here to the way it's written in this formula, but obviously that doesn't matter because we're ultimately adding things. So I'm going to say, so it's Q3, I did that at the end, 1.5 times IQR. Okay, and I hit enter and it gives me a value. And if I say what's the lower bound, then I'm going to say, let's do it the other way this way. I'll start with Q1. Okay, I'm going to add, and then in parentheses, again, because I want to make sure it gets applied correctly, I'm going to say 1.5 asterisk, and again, just select IQR and hit enter. Oops, sorry, except did something wrong there. So I was just thinking, I was like, that's really high. And in fact, my first clue that something is wrong is that the lower bound value, 164,329, is larger than Q1. It's actually larger than the median. That doesn't make any sense at all, right? It should be less than those things. Well, where did I go wrong? I took Q1 and I added 1.5 times IQR. In fact, I should be subtracting it. So once I've got this formula in here, I can just edit it. I have to do it up in this formula bar. So if I change this to a minus sign, then I get something very different. I get negative 132,455. Now, you might be asking yourself, you might be saying to yourself, that doesn't make any sense. And again, the thing to keep in mind here is that the statistics are just talking about the distribution of the numbers, right? It has nothing to do, just the same way that we know that people don't have, 0.5 or 0.65 children, we know that we cannot arrest negative 132,000 people. Well, I suppose we could argue about whether or not that's possible, but the point being here that all this is doing is giving you a frame of reference, and it's saying essentially what this is communicating to us is that there is very high variability in the number of people who've been arrested within this data set. And this too kind of gives me an inkling and says, I mentioned that I just in kind of looking at this data that I was pretty surprised at the way that the general pattern of numbers seems to change very dramatically. If we look at kind of the earlier part of the data set and the later part of the data set, it's on average, it's more than twice the number, right? So I am guessing that there was actually some kind of counting change that happened, and that's why we're seeing this irregularity. This is the kind of, even that alone, that sort of doubling is something that would raise my eyebrow, and I would want to say there's more to learn here about how these numbers are collected. And again, that goes back to making sure that we really understand how the data that we are working with was collected, what it means, right, before we start running a bunch of calculations on it or making claims about something being a lot or a little, etc. Because this is very common, right? There are all kinds of things that impact the actual data points that we get. It's a very human process, and we need to make sure that we understand and can account for that process before we start doing any kind of work on the numbers. So anyhow, for this week, we're going to focus on this. For the next week, we're going to look at another couple of kind of calculations that can give us some additional context. But hopefully this sort of jives with you all, and I look forward to going over it together in class this week.